Welcome to this training session on lithium-ion battery manufacturing. In this course, we will walk through the complete journey of how lithium-ion batteries are made, from the very beginning of raw material preparation, all the way to the final assembly and quality testing. Our goal is to help you understand each step of the process so you can connect your daily work in the factory to the bigger picture of battery production. Let's begin our journey from the front to the end of Li-ion battery manufacturing. Up to this point, we have covered the journey of lithium-ion battery manufacturing through three critical steps: electrode manufacturing, cell assembly, and cell formation and finishing. Each of these steps ensures that the electrodes are prepared, the cells are built and stabilized, and the electrochemical performance is secured. Now we move into step 4, packing. In this phase, the focus shifts from individual cells to the larger system level. Cells are grouped into modules, and modules are further integrated into full battery packs. This step also involves adding essential components such as the battery management system, as well as cooling or heating systems for safe and efficient operation. Packing is the final stage of the manufacturing process, where cells are integrated into a complete battery pack capable of powering electric vehicles, energy storage systems, and various other applications. In other words, this is where individual cells transform into usable, real-world energy solutions. In step 4, we move from individual cells to a fully functional battery pack. The process begins by connecting multiple battery cells together after surface cleaning, ensuring consistent electrical contact. These connected cells are then placed into a protective case during the modularization stage. Next, multiple modules are assembled into a battery pack, which provides the required voltage and capacity. At this point, a battery management system, or BMS, is integrated into the pack. The BMS plays a critical role in monitoring the charge status, lifespan, and cell balancing. Finally, the completed battery pack is installed into its intended application, such as an electric vehicle or energy storage system. This step marks the final transition from individual electrochemical cells to a practical power source ready for real-world use. Step 4, pack process, cells, modules, and packs. We begin with battery cells, which are the fundamental building blocks. Each cell chemically stores energy and typically provides 3 to 4 volts. The most common cell formats are prismatic, pouch, and cylindrical. Next, multiple cells are combined into a battery module. Inside a module case, cells are fixed side by side and connected in series or in parallel. Once the cells are covered and sealed, the module becomes a serviceable unit with higher voltage and capacity. Finally, several modules are integrated into a battery pack. The pack is the complete unit that powers an electric vehicle. It not only includes modules, but also incorporates a battery management system, BMS, and often a thermal management system to ensure safe operation through proper cooling and heating. In short, cells form modules, and these modules comprise the pack. This layered structure enables engineers to design batteries that meet the voltage, capacity, and safety requirements of various applications, particularly electric vehicles. Battery systems. Up to this point, we have discussed the manufacturing, assembly, and formation of battery cells. The final step in this process is building the battery system, which is what is actually installed in electric vehicles. This system starts with battery cells, which are connected into modules. These modules are then grouped together to form a pack. But a pack on its own is not enough. A complete battery system integrates several critical components: connected cells and modules, which store the energy; cooling plates and a cooling system, which regulate temperature and prevent overheating; a battery management system, BMS, monitors the health, charge, and safety of the battery; and finally, a battery housing, which provides mechanical protection and ensures safe operation. Together, these elements create a robust, service-ready battery system that can power electric vehicles safely and efficiently. Battery Management System, BMS. Now that we have examined how cells, modules, and packs are constructed, let's focus on the Battery Management System, or BMS. The BMS is essentially the brain of the battery. It monitors, controls, and protects the battery pack to ensure safe and efficient operation. Without it, lithium-ion batteries would be prone to overheating, overcharging, or deep discharging, all of which can cause failure or pose safety risks. As you can see in the first illustration, the BMS sits on top of the battery pack and manages the delivery of stored energy. Inside the BMS, there are several key components. A microcontroller that acts as the control center. Sensors that continuously measure voltage, current, and temperature. Switches that disconnect the pack when unsafe conditions occur. A cell balancer that equalizes charge across cells to extend lifespan. And in some cases, a communication interface to exchange data with external systems, such as the vehicle's powertrain control. In short, the BMS is what makes lithium-ion batteries reliable for real-world applications. It not only safeguards the cells, but also optimizes performance and lifespan. Structure of the BMS and module assembly. In this step, we examine how the battery management system is integrated into the pack, which is a collection of modules. First, the cells are connected inside the module. This is achieved through current collectors or contact tabs, which are joined using welding methods such as ultrasonic, laser, or resistance welding, and in some cases by screwing. The quality of these connections is checked by resistance measurements, pull tests for mechanical strength, and optical inspections of the weld seams. Next, the BMS cell sensing circuit, or CSC, is mounted. This circuit, located at the top of the battery module, enables the BMS to monitor voltage and temperature at the cell level. Before installation, modules may also undergo plasma cleaning to ensure the surfaces are free of contaminants. The illustration shows how these elements come together, with bus bars linking cells, a cell module controller on top, and cooling structures at the bottom to manage heat. Battery Management System, BMS. This slide illustrates the integration of the Battery Management System, BMS, into an electric vehicle. You can see here the battery pack installed in the chassis and the BMS positioned to monitor and control it. The BMS consists of several key components. Microcontroller. This is the central processing unit of the system, collecting data from sensors and executing control programs. Sensors. They measure critical parameters such as voltage, current, temperature, and the state of charge of the battery. Switches. These act as safety devices, capable of cutting power in the event of malfunctions or emergency shutdowns. Cell balancer. It ensures that all cells within the pack charge and discharge evenly, thereby extending battery life and maintaining optimal cell health. Communication interface. In some systems, this enables the BMS to exchange data with the car's onboard computer, providing diagnostic information and enhancing overall safety. Together, these elements ensure safe, reliable, and efficient battery operation inside the vehicle. This diagram provides a complete overview of the major steps in battery pack manufacturing. The process begins with electrode manufacturing, where the cathodes and anodes are produced by coating active materials onto thin metal foils. Next, in cell assembly, these electrodes are combined with separators and wound or stacked into cells, which are then filled with electrolyte and sealed. The third stage, cell finishing, includes formation cycling, aging, and testing to activate the materials and ensure stability and safety. From here, we move to module production, where multiple cells are grouped together into modules, complete with electrical connections and mechanical structures. These modules are then integrated into the larger system during pack production, where safety systems, thermal management, and the battery management system, BMS, are added. Finally, the complete battery pack undergoes vehicle integration, where it is installed into the car, ready to power electric mobility. This flow provides a comprehensive overview of how individual electrodes evolve into a fully operational battery pack for vehicles, step by step. This slide lists just a few of the many terms you have learned throughout this course. There are also separate courses, such as MBC 062 and MBC 052, that focus specifically on terminology. Please take note of these terms and continue to become more familiar with the wide range of technical vocabulary used in this field. This slide lists the main references used in this training course. Whenever possible, the original sources have also been included on each slide. If time allows, I encourage you to explore them for deeper study. Some sources may not be fully linked, so please let us know if you find any gaps, and we will update them. All images, texts, and cited materials remain the rights of their original authors, and here they are used strictly for educational purposes. This marks the completion of all 4 steps in Li-ion battery manufacturing. Thank you.